This is just a video to help students with series for Calculus 2. While I'm not an expert, I'll do my best on this. The first one is -1 to the nth times n over 3n plus 1. We want to see if this one is a divergent or convergent series. We'll do the divergent test. We'll divide each of the values or the n's by n, and we see that you get 1/3 when you do that. So n divided by n and 3n divided by n, 1 over n. The limit of n as it approaches infinity. This equals 1/3. So since 1/3 does not equal 0, that is divergent. We'll do likewise with this one here. We'll divide each of these by n to the 6 on the bottom. And then on the top, I have to divide that by the square root of n to the 6. And we get 1 over the square root of 3. So that is not 0, so that is also divergent. Our next series, sine of n over n squared plus n plus 1 under the square root. Doing the divergence test, we remember that sine is just going to alternate between +1 and -1. So if we look at the absolute value test here, the absolute value of this, okay, we see that 1 over n squared plus n plus 1 under the square root is larger than the sine n over n squared plus n plus 1. Okay, so the limit of 1 over the square root of n squared plus n plus 1 is 0. So by the test, this one is a convergent series, since the limit is equal to 0. Now remember, with the divergence test, we have to remember that a limit of 0, it could be divergent or convergent. But by the absolute value test, we are convergent here. Okay, let's take a look at our next examples then. Okay, so the next one we have is 5n squared plus 4 over 3n squared plus 2n plus 1. Okay, so we're going to look at the limit comparison test here. So b, I'm going to make equal 5n squared over 3n to the 4th. Okay, that by limit, that one will be larger than our a sub n. Now that one is a simple p series, because if you look at when I substitute this in or simplify it, this is 5 over 3n squared. So for the p series, our power is 2, so 2 is greater than 1. Therefore, by the p series, this converges. So why do I have to do a limit comparison on this? Well, when you do the divergence test, I divided every one of these by n to the 4th again. So the top is going to be divided by n to the 4th, and we see that that will be a 0 on top, and this will be 3 on the bottom, so that equals 0. So that is inconclusive by the divergence test. So that's why you have to do the limit comparison test. I've chosen b sub n just to be the 5n squared over 3n to the 4th. We know that that will be larger than our original series. So then what I need to do then is I have to do by limit test, comparison test. I'm going to take the ratio of them and take the limit of it as n approaches infinity. Okay, so therefore I'm going to take my original series, an, and divide it by my new series, b sub n. Okay, and when I divide them, I remember I'm going to take the first one and then multiply that by the inversion of the first one. So I've got 5n squared plus 4 over 3n to the 4th plus 2n plus 1 times 3n to the 4th over 5n squared, if I invert that. Now what I'm going to do again is I'm simply going to divide everything by n to the 4th. And doing by n to the 4th, I'm left with 3 on top and on 3 on the bottom. Now remember that n is approaching infinity, so everyone else becomes 0. So this is 3 over 3, which indeed is a limit. And because our p series converges, and our limit is equal to some value, the a sub n, my original series, would then converge. Okay, my next one is a series to n to the nth minus 5 to the nth over 4 to the nth. So what I'm going to do is I'm going to divide each of these, okay, into that. So then I've got this will be 1/2 to the nth, and this will be 5/4 to the nth. So I'm just separating this out into two different series by dividing that one in there and dividing that one in there. Okay, so these are geometric series. So there's two geometric series here. So my r is 1/2 for this one. That's less than 1. That converges. This one's 5/4, so my r is greater than 1, so this one diverges. So since this one diverges and that one converges, the original series has to diverge. They both have to converge in order for the original series to converge. Okay, so now I've got a to n equals 1 over the square root of n cubed. So that's 1 over n to the 3/2 power. This, of course, is a p series, and our p is 3/2, which is greater than 1. So the whole series converges. All right, so next one. So this one is a direct comparison test. We have 1 over e to the n plus n. So by direct comparison, I'm going to choose my b sub n to be larger. So that's just 1 over e to the n. I'm just getting rid of the n. So this one here has a smaller denominator, so it has to be larger. So this one is a simple geometric series, 1 over e. So my r is 1 over e. So since r is less than 1 and it converges, the original series then has to be convergent because of the direct comparison test. So remember, you have to choose a b sub n that's larger than your a sub n in order for that to work. Find the sum of the geometric series 5/3 minus 10/9 plus 20 over 27. We need to find r first. So r is going to be the second term divided by the first term. So negative 10 over 9 over 5/3. That equals minus 2/3. So we take the absolute value of that. That equals 2/3. Since that's less than 1, this geometric series converges. So to find the sum, that's just a1 divided by 1 minus r. So I'm taking 5/3 divided by 1 minus a minus 2/3. Okay, and that equals 1. So that's our sum for that series. Good. So now we have 1 over n times the natural log of n. We're going to do the integral test on this. We have to remember that it must be continuous, and it is. It must be positive, which it is, and it is decreasing. Well, we have everything on the bottom here, so it definitely will be getting smaller. So now we're going to take the integral. Since this one starts from 2 to infinity, it'll be from 2 to infinity. And then that's 1 over n natural log of n. Now that involves the u substitution, which I've included down here. Okay. So the u is the natural log of n, the u is 1 over n, and you can pause the video and see how I get n natural log of n from that. Now this has to diverge, everything's on top, so that the original series also must be divergent. Okay, now we have the 6 plus n over 5 plus 4n to the 2n. Every time I see something like this, I think root test. So we're going to take the nth root of this and get 6 plus n over 5 plus 4n squared. So I'm going to divide each by n, and then I'm going to see, okay, I'm going to see that, again, we're taking n to infinity, right? Okay, so this is going to be, these are all going to equal 0 here. This one here is going to equal 1, and this is going to equal 4. Because remember, 6 over n as n goes to infinity, that's 0, this one's 0. So this is 1/4, and then of course we square it to get 1/16. Since 1/16 is less than 1, it converges. Okay. And now our last test here, the ratio tests. We have the original n plus 1 factorial over 2n plus 1 factorial. So I'm going to add 1 to each one of these and then divide it by each one of these individually. So I've got n plus 1 factorial over 2n plus 1, and that all factorial. And then I'm going to times that by the inverse of this just to make this simple so it's not too crazy for me. Okay, so now what do we do next? Well, we have to write out what each of these factorials are and extend it. Okay, first of all, we have 2n or n plus 2 factorial over 2n plus 3 factorial times 2n plus 1 factorial over n plus 1 factorial. Okay, so this one, remember, we're going to decrease by 1 each time. So this is n plus 2 times n plus 1 factorial. Because remember, factorial goes, if let's say the factorial of 6. 6 is 6 times 5 times 4 times 3 times 2 times 1. So every time you decrease by 1. So this is n plus 2 times n plus 1 factorial. Okay, on the bottom, it's 2n plus 3 times 2n plus 2 times 2n plus 1. This one I'm just going to keep original, and I'm going to keep this one original. So why do I do that? Well, because I know the n plus 1 factorial will cancel out that n1 plus factorial, and the 2n plus 1 factorial will cancel that one out here. So I'm left with, okay, n plus 2 divided by 2n plus 3 times 2n plus 2. Okay, now what I did on the bottom is I just FOIL that out. Okay, and I divide everything by n squared. So I see that the top is going to approach 0. Okay, so since this whole thing is 0 and it's less than 1, the entire series does converge.